This video is one of a group that looks at how to name compounds, and specifically in this video we'll be talking about how to name ionic compounds that contain transition metals. And in order to do that, you'll want to already know how to deal with ionic compound formulas and naming fixed charge metal ionic compounds. Big lot to say there. So let's start with checking out our periodic table and finding out where those transition metals are. So you'll notice that we've talked about in the fixed charge metal video that these first two columns were fixed charge metals. And in fact, we said the alkaline metals, which are the first column, always had a +1 charge, and the alkaline earth metals always had a +2 charge. And then we talked about silver always has a +1, and aluminum always has a +3. Now, our metals run pretty much over here. I have nonmetals on the side of this line. That's the separator. And on this side I have metals. So here's my fixed charge metals over here. These guys, which are the rest of the metals, are transition metals. Transition. And transition metals are a little bit schizophrenic when it comes to their charges, because sometimes they're +1 and sometimes they're +2 and sometimes they're +6 or +3 or whatever, depending on what compound they're in, who they're paired with, and how many of the metal there are that are present. So when you're looking at a compound formula and you see one of these metals, you know, hey, I'm going to have to name that a little bit differently than I do if I'm looking at metals from over here. So here's the rules, and you want to keep in mind here that the purpose of some of this information is that now we can't just look at the periodic table and decide what the charge of the metal is. So the name has to tell us what the charge on the metal is so that someone can come up with the correct formula from the name. So let's take, for example, let's say we had iron Fe2O, and we needed to name that. So first step would be to name the metal, which is iron. Second step is going to be determine what the metal's charge is, because iron is a transition metal. You can check your periodic table there just to verify for yourself. What we know about ionic compounds is that the total charge of my ions here has to sum to 0. We also know that oxygen has a -2 charge, and I can tell from the formula that there's only one of them. I know from looking at the formula there's 2 irons, each of which I don't know the charge of. So there's 2 question marks there. That has to add to 0. So pretty much, if we think about this in terms of algebra, I have 2x, that's the charge on the metal that I don't know, minus the 2 that I'm getting from the oxygen. The whole thing has to add to 0. So 2x will equal 2, just adding 2 to both sides, and solving for x, I'll end up with x equals +1. So that tells me that each of those irons are a +1 charge in this compound, which makes sense because this gives me +2, that adds to my -2, and I get 0. So back to the name here. Now that I know that iron is a +1 charge, I need to put that number as a Roman numeral in parentheses right after the iron. And if you don't remember your Roman numerals, let me list them for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Secondly, I'm going to name the nonmetal with an "-ide" ending, just like I did with an ionic compound where I had a fixed charge metal. So in this case, I've got oxygen, which becomes oxide, and I've got my name all finished. Okay, let's do this again. I've got COCl3. I checked my periodic table first to verify whether that CO, which is cobalt, whether that's a transition metal or not. It is. And so I can name cobalt first. Looks like I had some extra stuff here that I didn't need. And now we need to figure out the charge on the cobalt, so then I'm going to put in parentheses. So I check out my cobalt. I've got 1 cobalt and I've got 3 chlorines. Each of the chlorines, I can check the periodic table and find that their charge is all -1. So that means I have a -3 coming from the chlorines. I've just got the 1 cobalt. and the whole thing has to add to 0. So what is -3? What do we add to -3 to make 0? Well, we add +3. So my cobalt must have a charge of +3. That is then what I put into my parentheses, a 3. And then I finish out by naming my anion, which is chloride. I have iron and some sulfates down here. So I've got iron, and then a Roman numeral, don't know what it's going to be. Sulfate is a -2 charge. I have 2 irons. I don't know what their charge is, but I know that it's got to be summed to +2, because I've got to cancel the -2 so that the whole thing equals 0. So each of my irons should be a +1. So I put a Roman numeral 1 and finish naming. And since this is a polyatomic ion, I just name the polyatomic ion. No fancy ending. Let's do one more. I'm going to erase this so I have some space. Let's do PT. Let's do PT2CO3. Okay. I don't know that this compound necessarily exists, but it will serve as an example for problems that you might have to solve on your homework. So when we look at this time I've got a little bit of platinum and some carbonates paired up with it. So I know that the name of my metal is platinum, so that's where I'm going to start. And then the question becomes, what is the charge on the platinum? Well, I'm going to check my carbonates, and each of those is a -2 charge. And I know there's 3 of them because I can see that here in the formula. That means I'm getting a -6 for my anions. I have 2 platinums, and I don't know their charges. So it's kind of like saying 2x minus 6. And we know the whole thing has to equal 0. So 2x will equal 6, so x will equal 3. So it's platinum 3 carbonate. And I need to get rid of my platinums here because I'm not going to have enough space. Carbonate. And there's the name.